Thank you, Sally, and thank you for coming to hear this somewhat obscure topic, which I won't read. So, what is a modern health transition? British data, life expectancy, what you're meant to see is that although there was change in life expectancy at birth, in particular, the bottom line, before the late 19th century, the line gets a lot steeper in the late 19th century, so that people began living longer and a lot longer, really around, looks like 1870s, 1880s, 1890s, and the line continues to be steep. If we went on through the 20th century, we see it continues to improve. Now that's British data. We happen to have good British data for the 19th century. Across Europe, not exactly the same years, benchmark years, but similar story. You see the English data there. Sweden is interesting. It actually begins increasing earlier than some other countries, but even Sweden then accelerates at the end of the 19th century. We can move on, look later in the 20th century, and again we're seeing pretty big increases in life expectancy in relatively short stretches of time around the world. And I don't know what anyone's preconceptions are about this. In some ways, the most interesting here is the bottom line, sub-Saharan Africa. So you would know that growth rates, economic growth rates in sub-Saharan Africa in that first period from the 1950s to the 1980s, by and large, were not very good. And by the end of the 1980s, there was a lot of shaking of heads about what's going on in Africa. And in fact, in that same period, life expectancy was improving quite dramatically. And it's saying that what we're doing here is looking at indicators of health, in this case life expectancy, that do not correlate perfectly with economic growth, standard measures of economic growth. It's a different view of change over time. And in a way that's a good thing, because if in fact these health indicators moved exactly with economic indicators, with per capita income, you wouldn't need to go and look at anything else. Per capita income would tell you everything. So they're different, and in fact we can say something about the reasons why they're different. And this is it's the most economics-y part of the talk here. So the idea here, Sam Preston, a demographer, in 1975, very famous article, drawing upon an even more famous article by Robert Solow in the 1950s. As you move out along the horizontal axis, income is increasing. As you move up the vertical axis, people are living longer. At any point in time, more income will give you a greater life expectancy. The change over time, though, is a combination of getting more income, moving along the line, and the line itself shifting because of technology and organization that allows us to deliver better health with the same income. So it's technological change, in effect. And that was what Solow said in the 1950s, and that's the origin of the Solow growth model in economics, adapted to health. And the particular argument here is that we began to see big shifts in this line for health in the later 19th century. That's why we're getting that acceleration. It's not that income growth accelerates in quite the same way. It's rather the shifting of the lines. Technology, organization, knowledge, social capabilities, a variety of things. And in the background, of course, it's under the germ theory of disease, the public health provision, recognizing that you really have to get clean water into a city, you have to take care of sewage, you have to put the investments in place for that, and actually doing it. So I'm going to end up talking about not life expectancy, but stature, or height. And just as a quick slide before I introduce that, to show that the pattern of change in stature sort of follows the same, to the extent we have overlapping data, we do see the same acceleration of stature change. not a lot of growth in stature between the 18th and 19th centuries, but from the 19th to the 20th centuries, people got a lot taller. And you would know this if you think of your parents, grandparents, great-grandparents, if you know their stature. In fact, they were not nearly as tall as you are on average. So before I go further, I should say one kind of methodological thing about giving a talk, that in economics, it's not like in other disciplines where it's rude to interrupt. In economics, it's rude if you don't interrupt. So with that in mind, guard.
One of those numbers labeled centimeters per century, sorry.
Some questions are easier to answer than others.
Read the slide.
But the details that don't matter. One detail will come back to matter. Let's look at France. How France, pretty robust set of ingredients. There's a reason towards the end that will matter. So, the motivation for the talk. Today, of course, we are now very interested in inequality of all kinds. And this might seem like, well, of course. In fact, economists were not super interested in inequality until very recently. And the reason is not because inequality didn't matter, but they couldn't persuade themselves there's a good reason that inequality would influence growth. So inequality mattered as an outcome, but as a cause of growth, it didn't seem to matter very much. And there's big literatures on this from the 1960s, 1970s, trying to find the growth implications of inequality and essentially failing. So they kind of gave up on it. It wasn't so important. But it came back towards the end of the 1990s, and now it's very much on the agenda. So we all care about inequality now. And we know that in many societies, inequality has ethnic dimensions. There's ethnic stratification within many, many societies, and this matters a lot. So that's the dimension I'm going to look for. Excuse me. And in particular, I'm going to ask, where did it come from? Have we always, to the extent you've had different ethnic groups, was it always there? Or is it possible that this ethnic inequality was actually generated by the way different ethnic groups participated in this big health revolution at the end of the 19th and into the 20th centuries? Is it something about their access to this big burst of improved technology, improved organization, that because of some disadvantages, that generated the inequality? Or was it there all along? Or did the technology, in fact, intend to diminish the inequalities that were there all along? Those are the sorts of questions I'm getting at. In using stature, the reason I use stature is I want to look at long-term change, and we just don't have other indicators of health for a sufficiently broad set of ethnic groups and a sufficiently broad set of societies to be able to do that. It turns out we weren't measuring life expectancy for ethnic minorities in many societies until the 20th century. And a great example is New Zealand. One of the examples I'll use is New Zealand, where they had perhaps one of the best vital registration schemes in the 19th century. So they knew, in New Zealand, they had the world's best infant mortality, the world's best life expectancy in the 1870s, 1880s. But they only had that because they weren't including the Maori. The Maori were not included in their national data collecting until the 1920s. So we can't use those kind of data to get at how the groups change, the relative position of the groups over time, because the data don't go back far enough. Canada is even worse. Of course, we still don't have great data on the Aboriginal population in Africa. I'm not going to talk about the Aboriginal population in Canada, but vital registration and health data in general were devolved to the provinces. So as in the US, actually in the States, so across North America, individual jurisdictions, states and provinces began collecting data at different times. So we don't have comprehensive national data on life expectancy until the 1920s. So again, we can't go back the way we would like to. So I'll use height, stature as an indirect indicator of health. And you can read the idea here. So essentially, it's childhood circumstance largely determines adult height. And that's the basic idea here. So, and it's really the sorts of ideas that influence child growth studies. And it's not, in the end, of course, about any one individual. It's more what happens in some kind of dominant way for a whole society. If in a society, a big group or subgroup in the population, as children, have a lot of dysentery, if they don't get proper nutrition, or if the children are sent out to work a lot at early ages, so the nutrition they have is being used for work rather than building the body, they will not grow up as tall on average. So it is a very indirect indicator, and it's worth saying that in general, in research on health, there are lots of different dimensions of health, and therefore lots of different indicators. We shouldn't take any one indicator, any one dimension of health as the story, and that's true here too. But I would argue this is one that is useful, and it helps that we can get data on it. There are 2 or 3 more methodological comments to make. So when we see a change over time in adult stature, or we see differences between groups, we're going to think that there's something different in the childhood circumstances, change over time or contrast between groups. We know that stature is heavily influenced, although our knowledge is rather imprecise, but we know that stature is heavily influenced by genetic composition, your DNA. And in fact, studies of twins beginning in the late 1980s and 1990s, before we did our sophisticated DNA decomposition that we do today, the twin studies told us that, as a generalization, in any society, 4/5 of the variation, statistically 4/5 of the variation, comes from genetic differences, not from anything about the way people live or their childhood circumstances. And of course, this proportion 80-20, it varies by society, it's not, but in general. So we know there's an awful lot of noise in the data we're going to look at. And that means, because in the end we don't want to look at the genetic side of it, we need a really big sample. For anything we do, we need lots of people, lots of observations, in effect to wash out that variability, the largest single source of variability, and just look at the changes coming from the 20%. Reflecting quote-unquote environmental influences, the net nutrition influences. There is in this literature an assumption that all populations have the same height potential. And this is a pretty strong assumption. I think it's helpful not to lean on it very heavily because it is very, very hard to prove it, to be completely persuasive on this. But it's part of ignoring the genes. So we're going to be careful with our methodology, our use of sources, in order to allow us to ignore the genes, but I will be careful about the comparisons across time, or sorry, across different potentially genetic pools, because, and then we'll come back and talk about that at the end. So the data have to be organized by birth cohort, so you only see someone's adult stature after they finish growing. So you're collecting data about people who've reached their 20s, but it's telling you something about 20 years earlier when they were young. So you have to organize your data by birth cohort. So it's kind of weird that way. Some effects are stronger than others here. That in general, stature does not change a lot over time. But within a society, there are big differences. Groups within society have different stature. You see this. It turns out the first representative sample, so fairly careful measuring of people, height and weight, on a representative basis, so drawing upon a census in order to develop your sample design, the first in the world was done in Canada in 1953. Before that, for any country we look at, we're having to find any circumstance in which people got measured for height, and an extension of this research on weight too. And in general, that doesn't happen, did not happen. The two groups that did get measured pretty systematically for quite idiosyncratic and different reasons, one was the military, so anyone going into some kind of military or police formation would be measured, and anyone going into a prison or a jail typically was measured across a broad range of societies. And sometimes they did a better job of measuring than others, but so those are our sources. I don't know of any other source that would reflect medical exams applied to large numbers of people in a society before the 1950s, in any society. The prisons you get women from prisons, and you do get some women in military as well, but it's true that this is substantially about men. In the end, the data, and I'm going to show you only data about men. One of the complications, you will get data on women, but it won't be a very big sample. So the prisons, I mean, the ratio of men and women in prisons, of course, so you get a lot of men and not so many women. The other kinds of issues that really speak to the last point here, that this is very sensitive to selection. The first women to be measured and appear in the military records that I know for most countries appeared as nurses. Who's a nurse? It's a very select group within society. The first generation of nurses in particular were very selected. So again, it's kind of a problem. The bigger point here, I'll stop in a minute for the questions. The bigger point is that the data we get are very sensitive to selection effects. So this is now an economics term, a kind of technical term, but you can see what this will tell you why. So if we look at two different, so this is a famous picture here that you will recognize. So if we're comparing prisoners from, say, the 1880s and the 1890s, and the prisoners from the 1870s were all in jail for drunken disorderly, and the people in the 1890s were all in jail for forgery. Those two crimes draw very differently from a class perspective, and you're getting two very different, you're selecting differently, and you just have to be super careful about this because they're really big differences. And it's both that people from different social groups grow up in different circumstances, so the causation or the determinants of their height will give the rise to this, but it's also that there is some degree of discrimination by height, so that taller people tend to go into higher class occupations by themselves, so that reinforces the effect. So you have to be super careful about selection effects here. And that, of course, interacts with the problem of you want lots of data. You're going out looking for data, but you find a big trove of data, you've got to be careful, because if it's going to be flawed by these selection issues, then maybe you can't use it. So Tony and then Stephen. The issue is, I would say there are two issues. One is, you're drawing together some evidence, and is it kind of coherent evidence about some subpopulation? But then the question of how you infer from that subpopulation to the population at large. And most of what you're suggesting is there's some questions about how you infer from the subpopulation to the population at large. And I think we all agree on that. On the other hand, if the source of the change if there's change over time, and the source of the change is public health, probably getting all those people who were jailed for drunken disorderly, they're probably a pretty sensitive group to the changes in public health that you want to get at. But you do have to be careful then about drawing assumptions about the population at large, absolutely. That goes back to the gender question too. So if what's driving this substantially is childhood circumstance, the boys and the girls are growing up together. And even if there is a gender disparity in the allocation of resources at young ages within a household, if that doesn't change over time, then the trends you're going to see from the boys probably are going to be relevant to the girls. And that's an empirical question, of course, that may be hard to answer, but it's because a lot of this is coming, the kind of causation here means that as long as we're careful to say we're only looking at these subpopulations, it probably does have some relevance more broadly, but we'll come back and talk about some of these issues. Steve? I think you'll see some in a second, but I say 200. So if I have a table, if I'm doing means, averages for a group and I'm doing height, I kind of want to see 200. But it does depend on, so in a table you can do a difference of means test and you will get significance if you get a big enough difference between the cells, even at less than 200. We know that height in any population is largely normally distributed. And that's largely for genetic reasons. And that helps. The statistical analysis of this is more straightforward than it might otherwise be because of that normal distribution. So that means you can do these difference of means tests, etc. So some literature. So this is just to show you this is not part of the talk, but this is Canada. This is a paper I did with John Cranfield. The furthest line over is the average stature of Canadians who served in the Union Army in the Civil War. Canadian born. The next line is Canadian born in the Kingston Penitentiary. Everything's by birth cohort here. The pinkish line, I think that's the South African War, the Anglo-Boer War, the Second Anglo-Boer War. So Canadians who enlisted in that war. They're a lot taller, you can see. The line crossing it, that's World War I. We have lots of data from World War I. And then the first line that's got an upward slope on it, that's this 1953 survey done in Canada. And then the latter lines are modern surveys, I think. Yes, 1971, 1994, 2002. And there are a couple of things to take from this. At any one birth year, what appears to be the average stature differs. And that's the point about selection. Each source is giving you a different slice of the population. You've got to be really careful when you compare different sources here. So that's a methodological point. But the larger thing is there's a pattern here. We don't see increasing stature in the 19th century. Whether we look within a single source or with care, compare sources, nothing's changing. We're not getting improvements in stature for people born in the 19th century. But look what happens after 1900. It's almost like you turn the century and suddenly we just shoot up. It's a big change. So this is a rather marked change from the sources. So we can tell a story here that's consistent with the bigger literature on the modern health transition. So the black line there. So Canadians who enlisted in the Union Army in the Civil War, born in the 1920s, were taller than Canadians born in the 1940s, or 1840s. To get into these data, you had to be 21 years old. So the war is.
So what happened over the 1840s to break it down?
Don't know. Sorry?
That's the birth year, so if they were 40 years old when they went into the army, or the next guy was 32 years old, the next one was 20.
Yes.
So they were getting smaller as they.
40-year-olds didn't last.
The black line, yep. I forget. I think something is known about it. I think you know birthplaces, you know where they're from, but I forget. Yeah, there probably were some African Canadians in this. I don't know how many. They would have had to have been in Canada for their birth, so they would have. So they're not people who fled in the 1850s. But there'd be some probably. So one, an implication of what Gard just pointed out. So when you look at a source that just takes data from a single point in time, so any of these wars, in order to compare one birth group with another birth group, what you're doing is comparing 20-somethings with 40-somethings. And if you think back to what I said about selection effects, you have to wonder a little bit if the reasons why the 40-year-olds go to the trenches and get blown up might be different than the reasons why the 20-year-olds go to the trenches and get blown up. So you could worry a little bit about that. It helps to have a source that is not backing out cohorts from essentially a single sample. So the war is like a sample, a single survey. It helps to have a prison where over 40 years you're seeing people going in, so you're not relying on this kind of problem. So there's a kind of corroboration about using different sources in the overall pattern. So within all this, I'm going to look at ethnic differentials. So what do we think about ethnic differentials in stature? Many societies you see differences in stature, and these quotes are give you a sense, and after the first one is probably the most interesting. So why are the Mayans short? If you go to Guatemala, the Mayans are short. Why is that? Is it genetic? Or is it their physical circumstances, their physical standard of living when they're young? And this is saying, and I would argue that it's substantially the latter. It's not a genetic characteristic. They can be tall. And in fact, we know this, not here. Michigan anthropologist named Barry Bogan has done lots of studies of Guatemalans in the U.S. And just as the Japanese, just as the Chinese, so also the Latin Americans, the second generation in the U.S. just shoot up in stature. So it's not to say there are no genetic differences, but the big fact about they're so short in Guatemala, that is substantially about social conditions in the country. Tony. Yeah, we're talking about class effects. That's what we're talking about. That's exactly what we're talking about. Yeah, I agree. Yeah, and not just Mexico. That's the point of this.
On the topic of possible theories for different types, a number of years ago I read that people that had their diet was basically marine based were shorter than inland folks.
Yeah, it could be. You would have, in order to make that argument on a systematic basis, it's true many coastal peoples are shorter, but it's also true incomes are lower in many coastal communities. Fishing-based communities tend to have lower incomes. Yeah, I think we have Captain Cook a few slides on here. We'll come back to him. But I mean, it's true in general that different kinds of diet will make a difference. What's hard is to control for enough things to really narrow it down. So I say that everyone has the same potential stature if diet's the same. My doctor, at the time South Asian, objected. How do you know that? Because you never get the Europeans to eat all the rice we do, and you never get the South Asians to eat the wheat that you do. So how do you know? And it's true. It is hard to control, to make that really persuasive. So, one more comment? Some, yeah. I mean, so much of course, there's a massive literature today on different kinds of nutrition and health, different dimensions of health. It's in the newspaper every day. On stature specifically, we tend not to look at stature as an indicator of health anymore. Once incomes are high enough, it ends up not being super interesting. That's part of why it doesn't get looked at, but there has been a lot of research on stature and the evolution of stature over time. In physical anthropology, in human biology, in economics. Sociologists, when they look at height, they're often looking at the reverse causation. They're looking at heightism. But related literature. So I should maybe keep going here. So I think I've said all this. The last point, I'm talking about ethnic differentials, but what is ethnicity? Complicated. I'm an economist. I'm not an expert on this. It is important to have your eye on that question. Any of the sources we look at, each of them, to the extent they identify different ethnicities or you infer different ethnicities, you have to identify how you're doing it. And then, of course, there are questions about language. How do we talk about different ethnicities? And it's murky waters here, so I'm going to try to be fairly explicit about how I'm doing it as I move along. So today, this is drawing upon 3 papers. Research is going on in all of them. South African research, this is substantially about the colored population, and I'm just now getting data for the African population, blacks in South Africa. So the New Zealand, this is really an installment on a bigger paper looking at the Maori in New Zealand. And the Canadian paper with John Cranfield, notice he's not here. I can say whatever I want, is French English, and there's more of that going on too. The bigger frontier for Canadian research, though, is the Aboriginal population in Canada, different Aboriginal groups. Part of why this is possible is there's one source that is a great source for a bunch of different societies. And that's World War I. And it's really reflecting the British Empire. So this crazy British Empire, the British go out and they occupy different ecological environments in different latitudes, different parts of the world. They create little mini Britons in different parts of the world, but they're also indigenous populations. So we can do the kind of comparison between European descended populations and indigenous descended populations, and even mixed race populations in different environments using World War I. And it gives you can see why there's a potential comparative dimension here. This does tell you just the size of the enlistment in various societies and the data that I'm using here. Just a quick background. So I'm going to start with populations. These are the case studies I'm going to do. South Africa, New Zealand, and Canada. South Africa, I'm going to comment about coloreds versus whites. New Zealand, Maori versus white, or Pakeha, as they say in New Zealand. In Canada, it's going to be French descended versus other descended in Canada. And it helps to have a sense of the size of the different groups here. So the South African coloreds. So the 3 case studies I'm going to run through. The coloreds, I didn't know much about them until I began researching. It's just super interesting. Completely blended, completely mixed. So there are black-white unions giving rise to children in the 17th century. The Dutch did not have a prohibition on interracial unions in the 17th century. That only came in the middle of the 18th century. You also have slaves that are not local Africans, but brought in from up the coast, up the Atlantic coast, or up the Indian Ocean coast. So different African peoples are brought down, and they're mixing. And you have a big population of slaves brought from Java. The Dutch are bringing them from Java and from other Indian Ocean destinations. So it's a very mixed population, and even within the colored population in South Africa, they're identifiable different groups. It's a classic example of a race, and it is legally defined as a race in South Africa, that doesn't have a genetic basis. It's clearly constructed. And that's kind of interesting for me because I'm a little bit worried about these genetic influences, and so having a group that's very blended is helpful to me. But very different social circumstances than the whites historically. So what we know from kind of obvious health indicators, so this is as early as we can get in terms of health indicators, 1930s. Enormous difference in life expectancy and infant mortality. And much of the difference in life expectancy, of course, is coming from very early life conditions, which correlates strongly with infant mortality. Infant mortality is when you have lots of ambiguities in your data and you're not sure what you're getting. Infant mortality is something fairly concrete, fairly, you know what you've got. There is a worry about what about the births that are not being recorded. But that's the only worry you've got. So very big differential. So we should expect to see some difference in early life conditions and some difference in adult stature as a result. I don't know. It's possible. I think with any of these sorts of, I worry about this even in Canada because of the Catholic concern to baptize everyone possible, and Protestants not baptizing until later. So I worry about unrecorded infant deaths among the Protestants in Canada. But there could well be biases here. By the 1930s, there's a lot of public discussion in South Africa. There's a royal commission, or equivalent of a royal commission, on the colored population, and another one on the poor whites, actually. So I'm inclined to think that by then the data are probably not too bad. Here's an example of the kind of source I end up looking at. We get these all across the British Empire, and they look surprisingly similar across the British Empire. It's an enlistment form for one of the coloreds in, I think this is World War I, maybe World War II. So we get a name, we get an occupation, we know where they're born. We often know parents or other family members. So if you have other sources you can go to, you can find out more about them by then finding them in this other source. In the case of South Africa, we don't have other sources. We will exploit that though in Canada. You'll see in a second. And here's the crude medical exam that's done as part of the enlistment. You couldn't sign up to join the military until you got measured, identifiable scars. For some reason, religion ends up being recorded together with the medical exam. I don't know why that is. So this is the result from looking at a bunch of data from World War I and World War II. So separating 4 groups, whites, colored, World War I, World War II, organizing by birth cohort, taking annual averages by year of birth, and truncating in order to keep some minimum sample size for each year. So there are people born earlier, but the cells have small number of observations. I throw them out. And so the lines between the wars could overlap if I used all the data, but there's a risk of being misled by that. And it's a pretty simple story, as you can see. The colors are a lot shorter, really totally consistent with the infant mortality. And it didn't change much over time. You can see the purple line up there, the whites who served in World War II by birth cohort, they're getting a little bit taller. There's an upward trend you can see there. It's not very vigorous, partly because the South African whites were among the very tallest in the world in this period. They had pretty good health to start with. And it's part of why the modern health transition, when it starts to deliver benefits of different kinds, including becoming taller, they've already got some of those benefits, so they're not getting a big bang right away. We can go a little further and control for obvious confounding influences, things that could affect what you've got. So you can organize for birth cohort. You could pool the data and have just a coefficient for ethnicity, or you could estimate separately and look at different occupational differentials. Remembering occupation, we think kind of symbolizes the class you came from, but there is also the worry that people migrate into classes based on their height too. So it's a little to be a little cautious with it, but it's just a way of controlling for other things. And look at the constant term, how different it is. So that to the extent we can control for obvious confounding variables, which is it's not very precise here, the difference survives. This is restricted to the Cape Province because that's where most of the coloreds were. Do have some data, World War II, on Africans, and this here it's not annual, it's a rolling average. And although I haven't advanced very far with this yet, you can see that there's a story that's going to emerge about Africans becoming shorter at a time when the whites and the coloreds were not getting shorter. So this is, of course, pre-1948, pre-apartheid. So there's a lot there before the victory of the Nationalist Party in 1948. So, conclusions from that case study. Whites are already tall in the 1880s. Maybe we're seeing a rise in the 1920s. Big difference. Coloreds are short. Certainly consistent with infant mortality differentials. Here, we can see that the differences, it's really from the World War I data, they tell us that the differences in stature predate the modern health transition. People born in the 19th century were already very different in stature. So this difference that exists today was not created by the way these groups moved into the modern health transition. It goes a long way back. You could maybe worry about genetic differences. I think the complicated genes of the coloreds, I think, make that a weak argument. And indeed, the genetic composition of the whites, the identifiable whites, is probably a little bit more complex than the whites want to recognize it. To the extent we can see the blacks, we're seeing a different experience. So, New Zealand. These are the data that were collected at the time. Very low infant mortality for the white guys, the Pakeha. Much higher for Maori when you get good data, which is really 1920s. Really big difference here. Very big. Both of them are declining over time, and they get close to each other in the 2000s. Since 2000, they've become pretty close to each other at very much lower levels. So there has been very considerable diminution of infant mortality for the Maori, but there's still a difference even now. And the health differentials around Maori and Pacific Islanders in New Zealand, it's the single biggest health issue in the country today in national discourse. Again, going back to the first data we can get on other kinds of health and dimensions of health, deaths, so mortality, cause-specific mortality, presuming we know why people died. And by the 1930s, we're starting to get good about this. Huge differentials here, just massive. This is a very unequal society in the 1930s, you can see. So there's big questions here about what's going on with the Maori in that interval. We take the World War I and World War II records, just as South Africa, and they're organized a little differently. You're just doing a rolling average, pooling them together. What you're seeing is that there's really not much difference. So you kind of have to ignore the black line. Just look at the blue and the red line. There's no consistent difference between the Maori and the Pakeha in the 19th century, but then they widen. The gap between them gets very big after 1900. This is from the military data, pooling World War I and World War II, backing out cohorts from these essentially two surveys, the survey of World War I and the survey of World War II. I'll just go on. Here's the prisons in New Zealand. And what's useful about this is it's telling the same story. The red and the blue overlap in the 19th century. So people born in the 19th century, Maori were as tall as Pakeha, but the lines diverge afterwards. So it's useful here because the prison data, not from all the prisons, have in fact the very biggest urban prisons, but from the prisons whose data have been available to us, it looks like there's a pretty clear story that is consistent with what we see in the military records. The military records give you more socioeconomic detail for the individuals, so you can do the kind of multivariate regression here. So it's a little bit like what was done for South Africa, but it's separating the wars here. And the omitted group, therefore the constant term, that's the white guys. So the bottom line is saying 67.6. That's the average stature for the omitted group in each regression, which is urban transport workers born in the late 1880s. It's the same in the two wars. So the people born in the late 1880s, the white guys born in the late 1880s, the same height as the white guys born 1910 to 1914. That's what that's saying. No change. So again, it's a pretty healthy society. It's a society that's not seeing this run-up of heights, as we saw in Canada, because they're already pretty healthy. So we're not getting the big increase quite as early as we got in Canada. But by putting in a separate coefficient for being Maori, we can look to see what difference that makes, controlling for when you're born and your occupation. That's the second from the bottom line here, and it's not significant. There's a difference. The Maori are a little bit shorter. The World War I cohorts, people born in the late 19th century. World War II, big difference. So these data, so organized differently, analyzed differently, are telling the same story, that there's a really big difference in the ethnic disparity from the late 19th to the early 20th century. And that is consistent with the onset of modern health transition. So you can start to wonder here, we're going to tell a story about this. So one more comment, and then we'll just see if there are questions. That I don't have the slide here that has Captain Cook in it. So we have a number of quotes. So before going back further in time, you don't have the data, you just have qualitative observations. And it turned out Captain Cook was one of them. And he arrived in New Zealand and he said, boy, these guys are big. And all the early European observers commented on how big and healthy the Maori looked. Then you start to see some anecdotal comments towards the end of the 19th century and early 20th century really saying they don't look so great anymore. So it's a case of this quantitative evidence is really following upon qualitative observation, confirming that kind of story. So, Sally? So, New Zealand, it's been a bigger focus for research, so we have modern surveys. Kind of complicated in South Africa to do this, of course, because you couldn't do these surveys before the mid-1990s, until after apartheid disappeared and the government got its act together and had resources to do surveys. But New Zealand has surveys, and they tell a pretty interesting story. Here, ethnicity is the modern, what we do in Canada today, self-identification. And you can worry a little bit about how that might be playing into what we're seeing. But the big story here is the Maori are just growing incredibly. So compare people born in the 1940s and 1950s with people born in the 1980s. Really, really big increase in stature. They just got really big. And what it brings to mind is the big decline in infant mortality that we saw a few slides back. And it's so big, in fact, that there's substantial convergence. There is a difference today, but not very big. You don't see much of a difference between the blue and the red line here. So here's a society that has moved beyond that big ethnic difference that appeared at the beginning of the 20th century. So it's a particularly complicated story because there wasn't a difference. You're really hard-pressed to see much of a difference in the 19th century, people born in the 19th century, between Maori and Pakeha. They are genetically different. So in this case, they're genetically different, but they're just as tall. It's a bit surprising because in the 19th century, the population of Maori was cut in half. The number of Maori alive in 1900 was half that of the number of Maori alive in 1800. It's a demographic disaster comparable to that of the Americas, the indigenous population of the Americas. And yet through that, the survivors were pretty tall. So there's a bunch of things, and that's true for the Americas. The limited research on North America would say something similar, actually. So that's one puzzle here. The second puzzle is this: after things got so bad, then the convergence in the 1970s, and how do we explain that? So that's why there's lots more writing to be done on the Maori. In terms of the theme that we're looking at here, the quick way to summarize it, the Maori did not benefit significantly, obviously, from the modern health transition, this package of improved health, until after World War II. But when they did, then they really did. And it has been considerable improvement. So last case study, Canada, and here I'm looking at French and English. Turns out, quick thing I have to say, the French are short. And it was one of the most dominant things in the Canadian data from the start. And for the longest time, I just suppressed it. I thought, in Canada, as an Anglophone, you can't go around saying the French are short. Well, they're short. and they're short in all kinds of sources, too. So there's no, I mean, our first response is, well, it's not really true, is it? So we'll look at this. So here's the Kingston Penitentiary, controlling for a bunch of things. If you are born in Quebec, you're an inch and a half shorter. It's pretty clear. Inch and a half's a big difference. This is World War I. Not a very good organization of it. The first set of bars, number one, that's people born in the 1870s. Second set of bars, people born in the 1880s, 1890s. The crosshatched one is Quebec, and they're shorter everywhere. So it doesn't matter which cohort you look at, they're shorter. World War II, just average height, people born in Quebec, about an inch shorter than Ontario. The Ottawa River is not very wide, but that's a big difference. It's a survey that was done. We don't have the microdata from the survey, but they did report, because this is Canada, they reported Quebec and the rest of Canada. And sure enough, a difference. We have lots of modern health surveys. They're actually not so great on identifying childhood circumstance. There's been a big change in understanding in the medical literature on determinants of adult health. And now we know that early life, so in utero, age of 1, age of 2, we know this matters hugely all through your life. But in fact, it was not accepted until the 1990s, and that means that all the surveys that were done are which we did lots of them in Canada, are relatively incomplete about early life circumstances. Lots of them don't tell you where people were born even. So it's a bit complicated here, but using the modern health surveys, and we're looking at differences between French and everybody else. French gets defined differently in different surveys here. And we're trying to control for income, trying to control for the kind of occupation as well. So I'll quickly summarize this. So there are a bunch of different surveys, different ways of defining what I'm trying to get at. Some just give you Quebec born, some give you Quebec resident, some give you French speaking, etc. And the important thing to observe is there are all those negative signs. French, it doesn't matter how you do it, doesn't matter which source you look at, the French are a lot shorter. If you were to look closely, both from source to source and then within each source by cohort, the difference is getting smaller. So there is substantial difference here. It's changing. So the long run pattern, from some of those regressions we know that it's not just about Quebec, it's being French is a big part of it. So if you just take cross-Canada data for those surveys that do tell you French language, Anita is left. But if we look at the Francophones in Manitoba and Saskatchewan, the Francophones in Acadia, and the Francophones in Quebec, put them in, they're going to be shorter too. So it's not just about Quebec. So it's a bigger kind of thing. So this is getting, so these surveys are self-identification of ethnicity to the extent they give ethnicity or its language at birth. So the Métis, or what are they? Are they modern Métis? Are they Francophone? So there's some other papers I've done looking at this, and one thing that jumps out is already by 1900, the Métis population in Canada was not substantially French descended. There's a lot more English and Scottish and Irish descended mixtures with the Indigenous than the French. So it's going to the Métis is not, it just kind of complicates things. It's not going to change the story a lot, I think. but it's a useful question. So the complication for me in this is that the French are short. Now we accept this. How do we understand it? It's complicated. Their social status, income, any measure of socioeconomic status in Canada, within Quebec, outside Quebec, was distinctly inferior until relatively recently, and maybe even now. So you can tell a class story with this. You can also look at culture. What are the foods we associate with Quebec? Maple syrup, tortillere, there are a bunch of things that are not super healthy here. So maybe there's something cultural in this. The French population in Canada is heavily studied by demographers because it's what they call a founder population. That a bunch of people arrived, not a large number, arrived by 1750. By 1760, then nobody else came from France, or hardly anybody else came from France. So they just kept on growing as a population within themselves, intermarrying within themselves. And certainly in rural areas, very little mixture with non-French descended populations. So it's a very particular kind of population. Is there something genetic here that we can talk about? And I'll come back to this later. That will come back. Indeed, yeah. No, my Franco-Ontarian great-grandmother was 5'1". So sure. We'll come back and talk about this. Is there a potential instance? So analytically, the problem is we've got too many different explanations here. This is a kind of complicated problem here. And if you look at the French in Europe, and that's why I pointed out in that first slide, the French are not notably short in Europe. If you think of Europeans today, you spend time in Europe, you don't say, oh, the French, they're short. Which in Canada now, so as soon as we get over the, can we really believe this, everybody says, no, yeah, I know a lot of short French, it must be right. But they don't say that in Europe. And even if there were, nobody says it's for genetic reasons. There's just too much mixing within Europe for that to be the case. And French-English differences, I mean, just think of the complications here. The French invaded England in 1066. Then subsequently, the Anglo-French then went back and invaded France a bunch of times in subsequent centuries. Huge amount of interaction here. So it's going to be really hard to tell. And even if you do look at the European data, the French have grown to be very tall, even if they were short earlier. And possibly the 18th century French were a little short. They've since grown really tall. And that was the point of looking at that earlier table. There's a lot of growth among the French. So it's really hard to think that it's a genetic difference. And yet, so the way I'm going to try to get at this, to take another look at it, is it turns out in this case the historical data are better than the modern data. This is different. I mean, other kinds of circumstances you use the historical data because you don't, you look at stature because you don't have anything else. You're kind of stuck. Here, the historical data actually are better, so you want to go to there. So we have all these men from World War I. We can find them in the 1901 census and get their household circumstances. And that census was particularly good about ethnicity. And they in fact asked, what was your mother tongue? What language did you grow up speaking? So we can identify amongst the soldiers in World War I, we can identify those that were born into Francophone families and born into Anglophone families. And then we have all these other, it was the first census in Canada that recorded income. So we can control for income too. So a bunch of different things here. And the sample, the analysis is about 9,000 soldiers in the end. So it's a big enough sample we can do something. So you have to use a particular kind of regression. Here, I'll move quickly. And the probably not super clear. This is a series of regressions here. So 3 regressions. A base regression in which we're just putting in controls for where you're born, your birth cohort, the occupation of the head of your household, so it's a measure of class in the household into which you were born. Then the next column, density tongue. So here we've introduced a measure of population density, so trying to get at the healthiness of that local environment in which you were born. I think I'm remembering this correctly. So this is rural versus urban birth now we're controlling for. And French mother tongue. And of course, what we're seeing is big negative here. So here we have controls for socioeconomic differences. We have the occupational controls, and in the next column, we have controls on earnings too. So it's not just occupation, but it's earnings. So this is really as sophisticated as we can get in terms of controlling for socioeconomic differences. And the French are still short. We didn't explain it away. We were hoping we would explain it away, but in fact it didn't. There's something you can do. It's a decomposition. Famous paper in the early 1970s by a guy named Oaxaca. Oaxaca decomposition allows you to say how much of the difference on average comes from the fact that one group might have a bunch of personal characteristics that in general are associated with shortness, whatever ethnicity you are. And how much of the difference comes from that, the particular profile of characteristics of the Francophone group, and how much comes from something you just can't explain at all, or how much comes from the differences in the way being in a particular occupation or being born in a particular population density plays out differently for French versus English. And so it's how much can you explain? And the endowments here, so endowments are the characteristics, the social profile of individuals. You can see, depending on how you do it, it's 20-25%. At most, we can explain a quarter of the difference between the French and English, using this fairly detailed data gathering, reconstitution from censuses and military, and then this multivariate framework that tries to exploit everything we can. We're not explaining a lot here. This differential remains. So you could try to improve this empirically, and I think probably this should be done, continue to do better on this, different ways of looking at it. But as we're saying that we've done this, this research went on from 2006 to 2012, and every time we added a refinement, the differences actually got stronger. It didn't get smaller. So we can keep on trying to refine and get better, but it's not going away. So the second last line here is the one that I think for me is the leading hypothesis now for understanding this. There is a paper, it's really just one set of researchers who think they have evidence from birth spacing that Francophones did not breastfeed nearly as much as Anglophones, which in the health conditions of the time, and indeed today, could well give rise to differences in infant mortality, which is what they document. They document infant mortality in Montreal, completely consistent with what we see here. They divide the Montreal population into French Catholic, Irish Catholic, and Anglo-Protestant. And that's kind of interesting because the Irish Catholic have the similar kind of socioeconomic profile as the French Catholic, so it allows you to get at that. In fact, the French Catholic have much higher infant mortality than the other two groups, and they attribute it to breastfeeding. And if that's true, they're the only ones who've said it so far, and you kind of want corroboration, but it could well explain early childhood nutritional differences that might give rise to differences in adult stature. A pretty tough thing to, I say we've got lots of data, we know a lot about the pre-World War I guys, the soldiers. Nobody tells us whether or not they're breastfed. So, so we have some limitations. So, I have interim conclusions here. Again, like South Africa, the modern health transition did not create the differential. This is not something that was created by the way these different groups went into the modern health transition. There are differences, and it's so different that we end up going back to the genetic question, and maybe there is a difference in the genes, even though there's lots of reason to think there isn't, and this literature ignores genetic stuff. You start to wonder, well, maybe there is something. It would explain it. Would explain the diminution over time, too, because over time, late 20th century, there's more intermarriage. So one comment that's been made is that, well, this is really an epigenetic story. And some of you will know what this means, epigenetic, something about the way your genes express themselves. So your genes aren't just genes, they affect your bodily development in ways that can be influenced by your early life experience. So is there something about that? And it's a black box at this point. There could be something here that all those francophones in rural Quebec, long cold winters, something happened epigenetically and they changed. That didn't happen in France. I mean, it seems possible. It's not very persuasive as long as you have no mechanism, And one of the complications here is that height, which we know is heavily influenced by your genetic composition, is actually really complex. The scientists are forever trying to figure this out, and there are lots of things now we can pinpoint to DNA that this chromosome on that side of the, et cetera, gives rise to this disease, or it interacts with something. So we're getting quite sophisticated in our knowledge. It's known that stature is influenced by at least 200 different locations in the DNA. So this is really complicated. So, and the biological science, the molecular geneticists have really not got very far with stature yet. And it's entirely possible one of the reasons they're not getting very far is that it's not all genetic, that there are environmental conditions that affect things and they don't take control of that. So, this is my last slide here. Going back to the original question of the extent to which the modern health transition created, removed, influenced the ethnic-based health differentials, using this rather particular indicator. It's not going to be true for Canada and South Africa, for the coloreds. There is some divergence in the early modern health transition if we're looking at blacks, but that evidence is still pretty incomplete. There is a divergence in New Zealand, and we're doing a lot of work right now on trying to understand early 20th century New Zealand, race differences in early 20th century New Zealand. More broadly then, bigger kind of observations, you do have to think a little bit about the capacity of different social groups, whether they're ethnically defined or something else, to take advantage of technological change when it comes along. So if we see, as we do sometimes, that some big new wave of technology improves everybody's welfare, but you have to have a certain level of income, you have to be connected to take advantage of it, or the first wave of people taking advantage of it are from advantaged groups, then you should expect to see some widening of differentials for a time because of this technological change. So there's some interplay here between technological change and ethnic disparities. And the final comment, and the South Africans are very big on this because they see the New Zealand research and they say study after study, inequality just seems to last forever. It's highly persistent. In any society we look at, inequality changes very little over time. But the South Africans look at the New Zealand data and they say, look at that, things can change. It does change. So inequality doesn't necessarily have to last forever. It can change, and in New Zealand it has done very substantially. So this is drawing together 3 papers or three research teams and trying to put a big story on it. I can't believe Tony doesn't have any questions. Tony must have a question. It's not immediately obvious what the mechanism would be. One possibility is vitamin D. So there's some, the bloom is off this year, but the last few years there's been a lot of interest in the influence of vitamin D. And when you look at these different populations, they are in different, very often regionally clustered, and they could have different exposures to vitamin D. So that potentially could be, and it could change over time with climate change too. It turns out that those New Zealanders not only collected really good infant mortality for the whites, they also collected good weather data. So we've had a PhD student who's done pretty sophisticated analysis using weather reports from different parts of New Zealand, and then identifying where every soldier came from, and the weather at their birth year. So partly was it a good harvest, but also extent of sunlight, and it doesn't end up explaining very much. It's a shame. New Zealand's a relatively small and among the whites, homogeneous population. So it's, potentially we're not seeing effects that might be there because of that. Stephen? Was there? Oh, good. So, yeah, so you should give me that reference. Yeah, so, it could easily be that the incomes were rising in England before in France, and there's some differences. Yeah, well, so I didn't really pursue the question of details of diet, but there are scholars who they think it's about protein. So it doesn't, and they'll say it doesn't matter what protein, could be fish, but protein is what really drives this. And so when they do their regressions, they try to find out what was the level of cattle per capita in the district you were born in. And, it's mainly Germans who do this. I've not gone that route. Yeah, most of the history of health literature is saying that hospitals are pretty much irrelevant until into the 20th century. But yeah, it could be. There's so many differences, and that's kind of the problem.
Is one that's really the biggest culprit
Yeah, so what we'd like to have is, so those 9,000 soldiers, we know where they're born. What do we know about public sanitation? Well, and the answer is nothing. So whether we could potentially do more that way. So certainly sanitation is recognized as a big influence here, and it's been a big debate. So we see lots of articles in this literature on diet versus disease. How much of it is diet differences? How much of it is disease differences? I'm probably more in the disease camp myself. Again, the Germans are all in the diet camp, so it turns to be a transcontinental difference in interpretation on this. But it's entirely possible that the Indian data, which are great on this, big country India, data collection all over it, lots of different heterogeneity within the country, and lots of people are looking at Indian data, have done, and will continue to look at Indian data. So we may, this might be a place where the data are good enough to allow a bit of a breakthrough. Did that answer?
I was just wondering if sanitation was a factor.
Yeah, but everybody would agree sanitation is a factor. There is difference about how much of a difference it was, and so empirically, this research on this has certainly points to sanitation being pretty important. The best evidence is really American evidence. So the Union Army, there's been a big study that takes Union Army soldiers and then follows them through to death, so through pension records. So, and then they have censuses that begin early enough that you can pick up information earlier. So that's been the most sophisticated work, and they're suggesting that sanitation does matter a fair bit here. It is part of why, so some of the urban effects, there's an urban penalty. Urban people are short until the 20th century, just as urban people don't live as long until the 20th century. But it turns out that there's some Scandinavian research on this, that even small villages, you don't need a very big urban area before you can get bad public health, bad sewage, contamination of water, etc. So the urban effect can come at a pretty small scale level, but it's a very powerful indicator in this. That Canadian regression had rural urban, but in fact it's just not a very precise measure in that. So that's one way to improve empirically, is to try to do more, and it's really trying to get at the sanitation question.
And in the Canadian context, there isn't much data that throws light on the sanitation.
There is some. I'm not sure that it's across Canada, but I have seen. It could be we could do more with that, actually. So, because big public investments in sanitation are visible, and municipalities had to finance them, they issued debentures so it's kind of on the radar. And there have been people who accumulated information on that. I've not thought it was really precise enough to help, but maybe I should go back and look at it. I mean, it certainly is potentially a very big influence here. I don't know about sanitation in Quebec. Montreal was a pretty unhealthy city. Montreal and Quebec City in the 19th century had infant mortality rates of 300, 350 per 1,000 live births. So super high, as high as you find anywhere in the world. So the Quebec population, there's some challenges there, and it's in that. So how much of that is sanitation? Tony? So on the first question of what's known about stature within France, there's a general gradient north to south. The north, it's taller than the southern, the Mediterranean people in general are shorter than Northern Europe. Normandy, Brittany, the areas that we know the majority, not all, majority of the people who came to Quebec are from, is sort of a medium tall. It's not a short region. It's not the tallest region. It's an interesting point that the gene pool there is partly Scandinavian too. So the latter question of what's going on in Europe, it's not just Europe. This has been studied. So the effects of economic change in the 19th century being injurious to your health, essentially. That's been documented in the U.S. most strongly, and it turns out that so you saw this here, the Canadians for the 1820s, 1840s, something like that is true for American-born as well. And Americans take great affront at this because this is a period in which they're growing very quickly, they're becoming a superpower, and yet they're getting shorter. And it's clear from the Union Army that they're getting shorter. So they call this the antebellum puzzle. And if you Google that, there's big literature on this. So it's industrialization in the 19th century in Europe and in North America, and I would think in some other environments too. And it's essentially income growth until you have in place sanitation, good water, etc., infrastructure, is likely to cause your health to be worse because people are moving to cities, more of the population is in cities, and working conditions are often not great. Think of Dickens, all we know about the 19th century. So, Adam? Yeah. So the regression did do earnings per capita within the household to try to take account of that, but there could be something more there. Yeah.
So this is not same question. So the about birth space in Quebec, which was the large families, the birth space was lower than in other.
Or the other way around. We're spacing lower.
Yes, the other way around. But in France, actually, French was about the first country to adopt contraception, so they had much lower birth rates in France. And one thing that's just come out, I've read the history of contraception, so I know this.
Oh, very good.
It's a fact that I'm familiar with. So I mean and one thing that's just come out this week is that if you breastfeed for much longer periods, right, the kids at what's it, the age of 30 or 40, more intelligent. I mean, it's just been released this week.
Yeah, but they're Brazilians. That's a Brazilian study. Yeah, that's true.
But I'm just
Yeah.
wondering whether the birth spacing
Yes.
situation in Quebec had some implications for the health and stature. I mean, we're learning more. I'm saying
Yeah.
we're learning more and more about this, and here's something here which would differentiate the Quebecers from the French.
Yes. So again, I think that'd be a useful reference for me to have this contraception question. When I gave this paper in Dublin once, some of this, they know about this stuff, and they said the big wet nursing industry emerged in the late 19th century in France. It's particularly important in France, and somehow that's so there are things to look at here. So that'd be useful in terms of the differential. So then you'd be saying, well, why is there a different breastfeeding tendency among the French in North America as opposed to the French in Europe? And that's not going to be easy to answer either. But it might well be that's the answer. It certainly could.
But it could be the birth spacing was one of the factors, right?
Yes. So
Really influences how long you can breastfeed for.
yes. So. The point that has been picked up in the literature is not so much French and Spanish, but again in Quebec, that there is it's really a biological argument that the degree of heterogeneity of the genes, so greater heterogeneity gives rise to a healthier population. So the homogeneity itself was a problem in the French Quebec population, is the argument. It's pretty tough to nail it empirically, but it could be there's something in that. There's a technical term, maybe somebody knows it, for this, starts with H, but anyway. Sounds good.